Looking at the very top, it says a matrix is an array of numbers composed of rows and columns. You'll need to be able to identify what the dimensions are. Okay, and that's rows and columns. So if I got a 3 by 2, that's 3 rows, 2 columns. 4 by 1, 4 rows, 1 column, etc. It says as n times m matrix has n rows and m columns. It's kind of what I was talking about. Each number in the matrix is what's called an element, and it can be labeled with that notation. But I'll explain that definition whenever we get to these examples. Okay, because it makes a lot more sense going through an example than reading that definition. So let's go through here. Make sure that you know, again, that you can identify the dimensions, because you're going to have to tell the calculator, hey, give me a 3 by 3, or give me a 2 by 2, or whatever it may be. So matrix A, what are the dimensions on that one?
2 by 2.
2 by 2. 2 rows, 2 columns. Alex, Shirley, matrix B is a what?
1 by 3.
Switch that. 3 by 1. 3 rows, 1 column. Freebie, C would be what?
2 by 2.
2 by 2. Garrett, D would be what? 3 by 3. Okay, so let's go to the element. If you ever have to identify a specific element or a specific number within the matrix, this is how this is read. Matrix A, second row, second column. So don't necessarily read that as 22. Read it as 2, 2. Second row, second column. So on that matrix A, I would look at the second row, the second column. So which number is this referring to? 5. Okay, B11, so first row, first column, that would be referring to what? 2. So C21, that's referring to what? Second row, first column, so -1. And if you have to write the little rectangles in there, do it. Okay. Row 3, second column, pi. Okay. So the big thing on those two, I would say being able to identify the dimensions is a little bit more important than identifying specific elements. Okay, so let's go. We're going to kind of go through here. We're going to read these definitions. And again, don't get discouraged if it doesn't make sense at first, because it's something completely new. Okay. Whenever you have these brackets, if you look down here, each one of these is considered a matrix, and they all have their own names here. So it says matrices can be used to solve systems of equation. Any system of equation can be written as the matrix A times B equals X. As is the coefficient. A is the coefficient matrix. And I'll expand on expands on the next paragraph. X is the variable matrix. B is the constant matrix. Multiplying each side by the inverse of A results in the equation X equals the inverse of A times B. Alright, so let's kind of dive into each individual matrix and look at what makes them. So a coefficient matrix is a matrix that consists of each coefficient of each equation in the system. Alright, so in our coefficient matrix, all we're going to have are the coefficients of these variables. Okay, well, we'll fill this in here in a minute. Wait until I get down there. The variable matrix is a matrix in one column that represents all the variables. Okay, so the only variables I have over here is x, y. So all I'm going to have in that matrix is x, y. On this last one, it's a constant matrix is a matrix in one column that represents each of the constraints in the system of equations. A lot of times I am going to refer to that one as the answer matrix. And we'll go ahead and fill this in. I refer to it as that because if you look at your system of equations, the answer to each equation, so equal 7, equal 15, that is what is going to go into that constant, or that answer, what I call the answer matrix. Just all the answers to each equation. So let's walk through this. So again, I need to fill in my coefficient matrix. First, I need to figure out what kind of dimensions I need to have in this matrix, though. How many equations are there? 2. How many different kinds of variables are there? 2. All right. Each row, and I would write this on here. Each row is going to represent the number of equations, or the number of equations is going to represent the number of rows. If you got 2 equations, you're going to have 2 rows. To figure out the number of columns, that is going to be the number of variables. Okay, we have 2 variables, x and y. So that tells me this is going to be a 2 by 2. 2 equations, 2 variables. When you're filling in the coefficient matrix, I would especially recommend that you do this early on until you really get the hang of this. I'm going to put x and y at the top of that matrix, and then below the x and below the y, I'm going to list their coefficients. So in the first equation, the coefficient of x is 2. In the second one, it's 4. For my y's, in the first equation is 3. Second equation is 7. In my variable matrix, I'm just going to list x and y. Whenever you're going through these, you don't always have to write it in this form. And the only one that you wouldn't have to write would be the variable matrix. But what that is telling you is whenever you get your answer, your calculator, you don't have to write this right here. Let's say it gave you that as your answer. That would tell you that the top number is your x value, the bottom number is your y value. So you just need to be able to read that answer. And it's always going to be in the format of what your variable matrix would be. Okay, so to get your answer for these problems, you're going to multiply the inverse of matrix A, and this is how this would be denoted. So 2, 4, 3, 7. So after you have your coefficient matrix in, you've got to denote on there that you want it to be the inverse of this matrix. On the left column, the far left column of buttons, there is a button below math that has x to the power of -1. If you hit that, it will raise that matrix to, it looks like it's the power of -1. I guess essentially it is, but it's going to say that that is the inverse of that matrix. If you can't find that button, please let me know. Okay, at the very top of the next page, you'll see that it kind of has a spot for that answer. You should have gotten 2 and 1. Okay, which means x is 2 and y is 1. Now, real quick, by a raise of hand, and if you didn't get the right answer, please let me know. Did anybody not get 2 and 1? Because I need to talk about what you probably got. Someone over here not get 2, 1? You?
Well, I fixed it.
Okay, but the first time, what did your answers look like?
Yeah, I just typed in the wrong number. I didn't really like.
No, you didn't get the kind of decimal system.
Yeah.
Okay. I was kind of hoping she'd gotten something else, and a lot of times, again, it's going to be if there's a mistake, it's going to be an operator error on this stuff. A good indicator is if you get your answers and they are just extremely long decimals, that means you probably put something in wrong. And you need to go back and double check. Okay, we're not going to give you a problem that has 20 decimal places in the answer. Okay? So always go back, always double check negatives. I'd say more times than not it's a negative that should be a positive or vice versa. Let's go to number 2. So I'm going to go through there. How many equations do I have?
3.
How many variables?
3.
So the first matrix needs to be what?
3 by 3.
3 by 3. So I'm going to fill it in. I'm going to label my columns X, Y, Z. And I'll list my coefficients. What are my coefficients for X?
2, 1, 2.
Mr. Capper, what are my coefficients for Y?
3, and then 1, because there isn't one for Y.
3 and then 1.
Yeah, because there isn't one for the
Negative
second
1.
one.
So what goes here?
1. Or no, 3.
3. Okay, what goes below that?
Nothing. Because there's not a Y.
Okay, what number represents nothing?
0.
There we go.
And then negative 1.
Awesome.
And negative 1.
Okay. There is no Y value. There is no Y value in that second equation, so you've got to put something into the matrix, or the calculator is going to give you an error. Okay, so you'll put 0 in there. The coefficients for Z, -2, -4, -6. And then you've got your answer matrix, which is 8, 1, 4. You should have gotten 5, 0, 1 for your 3 variables. Next, I want you to go to the word problem below. I want you to write the system of equations, and then I want you to solve it using a matrix. Writing that system of equations should be pretty easy, especially if you have paid attention.
Enjoy that, but I'm kind of bad at it, you know? That's right. I don't know.
These are the equations that you should have gotten on there.
What times for the last one? BCO? It's no back there.
Is it, wait. One column.
Alright, so Preston May, what did you get for the... How much did each sports channel cost? $2.80. How much did each movie channel cost? $10.80. And each concert? $3.60. Okay. So hopefully you can see the benefit in doing it this way versus last class. I think last class, you know, what the time it took for us to go through all these notes, it took us to go through one problem last class. Okay? So, this is using the matrix. We're gonna have quite a bit of time today. I'm gonna have you kind of do something else. Stop doing